Interstate 97 south of Baltimore, July 4th weekend. The temperature in Anne Arundel County that Friday afternoon hit 97 degrees. But on the ground, on the pavement itself, it was something else entirely. Concrete slabs on one of Maryland's busiest highways began to expand, then crack, then buckle. Sections of the roadway thrust upward, shoulder to shoulder, across all three northbound travel lanes. Steel rebar pushed through the surface like bones breaking through skin. The highway closed. Holiday traffic backed up for miles in both directions. Emergency repair crews worked through the holiday weekend to patch it, and in one critical stretch near the Brightview Drive overpass, the repairs had to be done twice. The pavement failed again before the crews were even finished. I want you to stop and hold that image for a moment. A federal interstate highway, built to last decades, engineered with reinforced steel and modern construction science, closed on the 4th of July of America's 250th birthday because the air temperature hit 97 degrees and the heat index climbed above 110. The road could not survive the weather it was built in. That is what I want to talk about today. Because what happened on I-97 was not a freak accident. It was not bad luck. It was a symptom of something much larger. And today, Tuesday, July 7th, 2026, I need to show you how much further this goes. The body of the atmosphere is still running a fever, and the data I'm looking at this morning tells me the pattern is not done with us yet. This is Arthur, and this is Sky Space Lab. If you are new here and you want weather coverage built on real model data and real numbers, not vague language and emotional speculation, hit subscribe now. It is free. It takes 2 seconds. In an active pattern like this one, it is how you stay ahead of what is coming next. Let's get into the numbers. First, the scope of what just happened. I think most people who watched the temperature maps over the last 2 weeks saw the colours, felt the heat, and understood it was dangerous. But I do not think most people fully absorbed the actual scale of this event. So let me walk you through it piece by piece. The National Weather Service issued a declaration that dangerous to record-setting heat was expanding across the eastern 2/3 of the country. Not a region, not a coastal corridor, not a heat island around a single metro area. 2/3 of the contiguous United States under one blocking high-pressure system. Over 200 million Americans under simultaneous extreme heat alerts. The NWS flagged heat index values reaching 115 degrees Fahrenheit in some locations. Overnight lows, and I want you to hear this part clearly, refused to drop below 75 to 80 degrees in major urban centres across the Midwest and Northeast. No recovery, no overnight cooling, no relief for the body or the infrastructure, day after day after day. Washington, D.C. broke its all-time July 4th temperature record. The capital hit 102 degrees, surpassing a mark that had stood since 1872. Philadelphia and New York City approached 100 degrees. Atlantic City, New Jersey hit 106 on July 4th, the highest temperature ever recorded in that city in the entire observational history. Boston saw triple digits. More than 100 individual record-high temperatures were broken or tied through Saturday night. More than 250 record-warm overnight lows were set in the same 4-day stretch. 154 locations in the United States broke or tied temperature records between July 1st and July 5th. I looked that number up this morning and I needed to read it twice. 154 locations, 4 days. That is not a heat wave, that is a generational event. Now here is the part that does not make the front page the way the triple-digit thermometer does. The heat index, what the air actually feels like to your exposed skin, and the physiological systems trying to keep you alive, climbed 10 to 15 degrees above the already record air temperatures at many locations. You're standing in 98-degree air, with a heat index of 112, your body tries to sweat to cool itself, but when dew points are 72 degrees, that moisture cannot evaporate efficiently. The air is already saturated, your cooling system slows down, your core temperature climbs. Cumulative heat stress is the clinical term. It is what killed at least 25 people confirmed as of July 5th. At least 22 of those deaths were in New Jersey alone. A 68-year-old man in Bethel Township, Pennsylvania, died after trimming bushes outside, in temperatures that had surpassed 100 degrees. He was not in unusual circumstances. He was doing yard work. Here is who needed to watch this the most. Elderly residents anywhere east of the Rockies. People without reliable access to air conditioning in Chicago, Detroit, St. Louis, Nashville, Kansas City, Cincinnati, and Des Moines, all of which were under extreme heat warnings at the peak of this event. Outdoor workers in Washington, Philadelphia, and Baltimore. Anyone near a dense urban core where the heat island effect pushes surface temperatures several degrees above what official airport instruments record. Infants and young children whose thermoregulation is less efficient than adults. The power grid did not just strain under this event. It hit the edge of its operational limits. The Department of Energy issued emergency orders authorizing every generator in the PJM interconnection region, which covers 67 million people across 13 states from Illinois through New Jersey, to operate at maximum capacity and bypass certain environmental restrictions. A second emergency order specifically authorized the use of backup diesel generators as a last resort. Think about what that phrase means in context. The largest interconnected electrical grid in the country needed its emergency backup systems on standby during a 100-degree heat wave. The PJM grid broke its own all-time peak demand record on July 3rd, and by that evening severe thunderstorms fired along the heat dome's northern edge and knocked out 250,000 homes in New Jersey alone, stranding people without air conditioning during one of the deadliest nights of the summer. New Jersey Transit suspended service. SEPTA in Philadelphia cancelled regional rail. Amtrak slowed train speeds on the entire Northeast Corridor because rail lines also expand under extreme heat, and high-speed trains on heat-stressed track are a safety hazard. And then, roads started failing. In Wisconsin, in Missouri, in Delaware, in Chicago, in Maryland. Reports came in from state departments of transportation across the region throughout the holiday weekend. The process was the same everywhere. Pavement materials that engineers had specified for a defined temperature range found themselves operating far outside those assumptions. Expansion joints in concrete panels designed to accommodate a certain amount of thermal movement, not enough for what July 2nd and 3rd delivered. Moisture that had worked into the roadbed over previous seasons weakening the subbase. Heavy holiday traffic pressing down from above. The concrete has nowhere to expand to accept upward. It heaves, it buckles. The structural failure is fast and dramatic when it comes. Engineers have a formal name for this. They call it exceeding design thresholds. I have a shorter way to say it. I call it a preview. So where does the situation stand today, July 7th? The blocking high that produced all of this is beginning, slowly, to shift position. The most brutal heat core is pulling back from the northeast. But I want you to be very careful not to confuse a temporary retreat with an end to the threat. The NOAA Climate Prediction Center is flagging moderate to extreme heat risk, continuing through the week of July 14th across a wide swathe of the country. The California valleys, the lower elevations of the interior west, the Plains Corridor, the Mississippi Valley, the Gulf Coast, and portions of the South Atlantic states. A slight risk of extreme heat extends even further north and east, into the western Great Lakes, parts of the Tennessee and Ohio valleys, until at least July 19th. Let me say that again. The CPC is flagging extreme heat risk through July 19th. Today is July 7th. We are 2 weeks from the outer edge of what the CPC is currently watching. This pattern is not finished. Drop your city in the comments right now. Tell me where you are and what today's temperature and heat index actually felt like when you stepped outside. I want to know who is still in the thick of this, and who thinks they are out of it, but may not be. What is driving this persistence into the next week and beyond? Multiple model ensembles are telling the same story. The ECMWF ensemble and the GFS ensemble both depict anomalous mid-level ridging building into the Four Corners region in the early part of week 2. 500 hectopascals heights reaching approximately 596 decameters during the middle of that period. I want to give you context for that number. Heights at or above 590 decameters at the 500 millibar level during summer represent a deeply amplified atmospheric ridge. This is not a routine summer high-pressure system. This is a feature that actively suppresses convection, traps heat at the surface, and maintains above normal temperatures across a vast geographic footprint. And that Four Corners Ridge is going to do one more thing. It is going to trigger the southwest monsoon. Intense surface heat over the desert southwest creates a thermal low pressure at the surface. That thermal low pulls tropical moisture northward into New Mexico, southern Arizona, and the southern Rockies of Colorado. The CPC is showing 20 to 40% probability for rainfall above the 85th climatological percentile across much of the southwest during the first half of week 2. So you have this striking duality: dangerous heat in the plains and the Gulf Coast, potentially heavy monsoon convection a few hundred miles to the west. That is the southwest in July, when a strong ridge parks over the Four Corners. Let me walk through the next 7 days with specific dates: today and Wednesday, July 8th. The most intense residual heat concentrates across the Gulf Coast states, southern Florida, and the southeast interior. Heat indices still running 100 to 105 across Mississippi, Alabama, Louisiana, and southern Georgia. Atlanta, Birmingham, Pensacola, Tallahassee. You're not done yet. Dew points in the upper 60s to near 70 are keeping overnight lows dangerously warm. When the overnight low in Birmingham does not fall below 78, the body accumulates a second consecutive night of heat stress without recovery. That accumulation is dangerous. Thursday, July 10th, through Saturday, July 12th. The GFS shows the ridge axis shifting westward. This begins to open the door for storm development along the northern periphery of the heat dome across Iowa, Minnesota, and Wisconsin. I need to be clear about what these storms are. They are not cold fronts. They are instability events, explosive convection triggered by the temperature differential at the edge of the dome, where cold air from Canada meets the hot, unstable air mass below the ridge. The GFS and the ECMWF both flag damaging wind gusts and large hail as the primary hazards from these systems. Some will be capable of producing winds in the 50 to 65 mile/hour range. Watch the afternoon and evening hours across the upper Midwest on both Thursday and Friday closely. Sunday, July 13th through Tuesday, July 15th. This is the period I'm watching most intently right now. The Four Corners Ridge rebuilds significantly. The NOAA CPC's probabilistic hazards outlook is explicit: moderate to extreme heat risk from California through the Central Plains, Oklahoma City, Wichita, Kansas City, Tulsa. All of these cities are in the zone for another episode of dangerous heat index values during this period. The GFS ensemble and the ECMWF ensemble both support this solution. The timing is about 8 days out, so there is natural spread in the precise daily details. But the broad pattern signal is consistent and strong across multiple independent modelling systems. When the GFS and the ECMWF agree on a significant heat event at day 8, I take that seriously. Now, I want to go deeper on something, because I think this is the part of the story that most weather coverage has not spent enough time on, and it matters for the rest of this summer and beyond. Let me take a step back from the immediate forecast and talk about something that puts all of this in a much broader context. Because the roads cracking on I-97 and the grid nearly failing in the PJM region are not just weather stories, they are infrastructure stories, and they are connected to a long-range pattern shift that I think is the most important atmospheric development of 2026. Here is a question I have been sitting with. Every engineer who designed the expansion joints on Interstate 97 had access to weather data. They knew Maryland gets hot in July. They designed for hot July weather, just not for this July. The specification gap is not ignorance. It is assumptions built on a historical record that has become less predictive of current conditions with each passing year. Amit Basi, professor of civil and environmental engineering at the University of Texas at Austin, explained the mechanism directly. Every time you design an asphalt or concrete mix, he said, you are designing for a certain range of temperatures. Extreme events expose the limits of those assumptions. The expansion joints on I-97 were sized for a range of temperatures. July 2nd and 3rd exceeded that range. The concrete had nowhere to expand to accept upward. This is not a problem confined to Maryland or to the 4th of July weekend. Reports of road buckling came from Wisconsin, Missouri, Delaware, and Chicago streets during the same heat event. State transportation departments across the region issued warnings to motorists about additional heat-related road damage, and this is from a single event, one heat dome that lasted about 2 weeks. What does this mean for a summer in which the ECMWF, NOAA, and Australia's Bureau of Meteorology are all aligned on an El Niño event that could challenge the strongest ever recorded? I want to spend time on the El Niño picture specifically, because I think it is being underreported in the context of this summer's weather. The Niño 3.4 index measures sea surface temperature anomalies in a specific area of the east-central equatorial Pacific. When that index reaches positive 0.5 degrees Celsius, El Niño is officially declared. We crossed that threshold in June. The index was already approaching positive 1, moderate El Niño territory by early June, and the forecast trajectory from every major center has it continuing to intensify through the second half of 2026. What makes this particular El Niño event significant is not just its projected peak strength, it is the background state it is developing in. The Copernicus Marine Service and the Copernicus Climate Change Service both reported in June that global ocean surface temperatures hit a new all-time record, the warmest ever measured in the full observational history. Every degree of additional warmth in the background ocean state gives El Niño more fuel to work with. It is like starting an already warm fire in an already warm room. The El Niño that develops on top of a record-warm global ocean baseline can produce atmospheric effects that a comparable El Niño on a cooler baseline could not. Severe Weather Europe's analysis, published this week, describes the subsurface Kelvin wave driving this event as a release valve, a massive pulse of anomalously warm water sitting below the surface of the equatorial Pacific is rising. When it reaches the surface, which the models suggest is already beginning, it reorganizes the Walker circulation. The Walker circulation is the east-west overturning circulation in the tropical atmosphere. When it weakens under El Niño, trade winds slacken, warm water piles up near the Americas, and the jet streams over North America rearrange. The subtropical jet strengthens. The Pacific jet extends further across the continent. Blocking patterns that would normally break down in 2 weeks can persist for 3 or 4. And that is the atmospheric mechanism behind what we just lived through. The blocking high that sat over the eastern 2/3 of the United States for 2 weeks, producing 154 temperature records in 4 days, killing at least 25 people, buckling roads in 5 states, and pushing the PJM grid to its operational limits. That blocking pattern was made more likely, more intense, and more persistent by the same El Niño dynamics that the models are now projecting will intensify further through the rest of the year. The NOAA Climate Prediction Center confirmed El Niño conditions were present on June 11th. NOAA flagged the possibility of a super El Niño developing as the year progresses. AccuWeather's summer forecast specifically noted that El Niño would have a growing influence through 2026, and that the combination of El Niño-enhanced subtropical jet activity and a warmer ocean background would mean above-average severe weather potential from the plains to the east coast, significantly elevated summer heat risk, and the potential for energy bills to soar as cooling demand spiked. All of that came true in June and July, and the El Niño that drove those outcomes is still strengthening. The Four Corners Ridge that the ECMWF and the GFS are projecting for the week of July 13th through the 19th, with 500 hectopascals heights near 596 decameters, is the next expression of the same pattern. A different location for the ridge center, a slight shift in the geographic footprint of the extreme heat, but the same atmospheric physics, the same driver, the same consequence for infrastructure designed for a cooler baseline. I want to be honest about what I do not know. The exact peak strength of this El Niño event is uncertain. There is meaningful model spread at forecast ranges beyond 90 days. The deamplification signal that the ECMWF ensemble mean has hinted at toward the end of week 2 could represent a genuine pattern change, or it could simply be the typical increase in model spread at longer time ranges that always occurs. I will be watching that signal carefully in tomorrow's model runs. If the ECMWF maintains its 596 decameter height signal through the July 14th through 17th period, that is the confirmation I need that another significant heat episode is on track. If the ensemble begins to show consistent deamplification, the heat threat eases somewhat, though above normal temperatures would likely persist across much of the country regardless. What I am confident about is this. The background atmospheric state heading into the second half of this summer is different from what it was in comparable periods in recent decades. The El Niño is real, it is intensifying, and its projected trajectory is supported by multiple independent global forecast systems. The ocean thermal energy that fuels atmospheric extremes is at record levels globally, and the infrastructure of the United States, roads, power grids, transit systems, has just demonstrated under live conditions that a 2-week heat dome operating at the level we just experienced can push it to and beyond its design limits. The question I am asking myself right now is not whether another significant heat event is coming this summer. The models, the ocean data, and the El Niño trajectory all suggest that more is coming. The question is which regions will be most exposed to the next episode, and whether the infrastructure and emergency response systems in those regions are ready for a second high-impact heat event within the same month. The Gulf Coast and the Southern Plains corridor are the areas I'm watching most closely for the next round. Oklahoma, Texas, Louisiana, Mississippi, Alabama, regions that have already been dealing with heat well above seasonal norms throughout June and early July. Another episode of heat indices in the 100 to 105 range on top of an already heat-stressed population and already heat-stressed infrastructure is the concern I am carrying into the next 7 to 10 days of this forecast. What is the connection between everything I have described? The road failures, the grid strain, the human deaths, the monsoon triggered by the Four Corners Ridge, the El Niño intensifying toward potentially extraordinary strength. These are not separate stories. They are the same story. The blocking pattern that produced the July 4th heat dome is one expression of a broader atmospheric reorganization that El Niño drives. As El Niño strengthens through the second half of 2026, atmospheric blocking patterns over the western and central United States tend to amplify and persist longer. The jet stream buckles into configurations that lock heat over populated regions for extended periods, rather than allowing the normal week-to-week progression of weather systems to provide natural relief. The FERC Summer Reliability Assessment issued before the season began warned of exactly this dynamic, that El Niño strengthening raises the risk of extreme heat events, and that geographically widespread simultaneous high temperatures reduce the ability of neighboring grid regions to share electricity supply when they are all at peak demand at the same time. That assessment described a theoretical risk. July 3rd made it a documented reality. I have tracked weather patterns and long-range atmospheric signals for a long time. The specific combination I'm looking at right now, a super El Niño tracking toward potentially exceptional strength, record global ocean temperatures providing the thermal fuel, a blocking ridge pattern demonstrating unusual persistence over the eastern United States, and critical infrastructure across the country already showing measurable stress fractures from a single extreme heat event. This is one of the more significant atmospheric setups I've encountered heading into the core of a summer season. The engineers who designed America's roads used the historical climate to set pavement specifications, temperature ranges, expansion joint spacing, load assumptions built on decades of data. Those specifications reflect the climate that existed when the data was gathered. What we are experiencing right now is a climate that is beginning to exceed those specifications, not occasionally, repeatedly. Mikhail Chester, a professor of engineering at Arizona State University, said it directly this week. Infrastructure has been designed for temperatures that have been relatively milder. The dynamics of the extremes are beginning to exceed the design thresholds. We built a country for one climate. We are operating it in a different one. What comes next? I am watching 3 things tomorrow. First, the latest ECMWF run, specifically whether it maintains that 596 decameter height signal over the Four Corners for the week of July 13th, or whether the ensemble mean begins to show the deamplification some of the longer-range signals have hinted at. That detail tells me exactly how severe the next heat episode gets. Second, whether storm development along the northern edge of the heat dome on Thursday produces organized severe weather across Iowa and Minnesota, or whether the instability stays fragmented. Third, the Gulf Coast heat index through Wednesday, because that region has not seen meaningful relief yet, and another 48 hours of 100-plus heat indices compounds the stress on a population that has been dealing with this for nearly 2 weeks. If you want those updates the moment they go live, make sure you are subscribed and the bell notification is on. In an active pattern like this one, the situation can shift meaningfully in 48 hours. Being ahead of that shift is exactly why this channel exists. Have you seen heat damage in your area from this event? Cracked roads, buckled pavement, warped sidewalks, tar bubbling through asphalt, power outages. I genuinely believe the official reports from state transportation departments have captured only a fraction of the actual infrastructure damage from this heat event. Tell me what you saw where you live. Drop your city and what you witnessed in the comments, and tell me if you're still in the heat or if you have finally gotten some relief. The number I keep coming back to from this event is not 106 degrees in Atlantic City on the 4th of July. It is not 25 deaths. It is 250. 250 record warm overnight lows in 4 days. 250 times, across 250 separate locations, the temperature that was supposed to fall and give the body and the infrastructure a chance to recover did not fall. The pavement buckled. The grid strained to its legal limit and then required emergency federal orders to stay functional. Transit systems in 3 cities suspended service, and 25 people did not survive it. The pattern is not finished. I will be here tomorrow with the latest data. See you then.